Today we will see the simplified version of problem 2.4 of quantum mechanics Griffith third edition. The problem 2.4 is calculate the expectation value of x squared, and p squared, also sigma x and sigma p for the nth stationary state of the infinite square well. Check that the uncertainty principle is satisfied. Which state comes closest to the uncertainty limit? First, we will find the expectation value of x. By definition, it is equal to integral between 0 to a x psi star psi tx, where psi of x is equal to square root of 2 over a sine kx, where k is equal to n by a. Without doing any calculation, we can confidently say that the expectation value of x is a by 2, because for infinite square well potential, the wave function is symmetric from the center. Both the left hand side and right hand side is symmetrical at the point a over 2, that is middle of the box. So expectation value, we can conclude that the expectation value is a by 2. Now, what is the expectation value of x square? By definition is equal to 2 over a, that is psi star psi. You are squaring it. So 2 over a, then x squared, here sine squared kx dx, which can be written as 2 over a, and this sine squared can be written as of sine theta, can be written as sine theta can be written as 1 over 2 1 minus cos 2. Using that relation, we have rewritten this as sine squared is rewritten as 1 minus cos 2 kx, because 2 theta 2 kx and 1 over 2 comes here. So now we will proceed with this. Now we got this relation. uh, Expectation value of x squared is 2 over a 1 over 2, then this integral part. Now here you can cancel this 2 and 2. So this will become 1 over a, then x squared. You bring x squared inside the bracket, then this will become x squared dx. And of course 1 over a, this x squared cos 2kx dx. Now the first one is, you will get, if you integrate the first one, then you will get x cube over 3. So if you apply the limit 0 to a, then you will get a cube over 3. But however, there is 1 over a here, which will get cancelled with this a cube. You will get a squared over 3. Then next 1 over a, the integral of this integral value is a by 2k squared. This I have given as a separate lecture, how we arrived this a over 2k squared. I have given in the description box the link for this derivation. So that is equal to a by 2k squared. Uh, Here also this a will get cancelled. This a will get. So you will get ultimately a squared over 2 minus 2 1 over 2k squared. But we know k is equal to n by over a. So you take first one as it is, then you replace k squared up as n pi over a. So this will become a squared n squared pi squared. Already there is 2 here. So now you take a squared outside. Then this will become 1 over 3 minus 1 over 2 n squared pi squared. So this is the expectation value of x squared. Now we got the expectation value of x squared. Then sigma x squared is equal to expectation value of x squared minus expectation value of x whole square. You know the we have just now seen expectation value of x is a by 2 whole squared, we have to take square. So the expectation value of x squared is this one. I brought this, and if you square it, you will get minus a squared over 4. So now you take a squared outside, and this will become last term become minus 1 over 4. Now you take this and this. The common LCM is 12. 12 you have 4 minus 3, which is equal to 1 over 12. So I have taken combined these two, and I brought as a single term 1 over 12 minus this term 1 over 2n n pi whole squared. Then we got the sigma x squared. Next is we have to find the sigma p. Then the expectation value of P is equal to, by definition, it is mass into the time derivative of the expectation value of X. We know the expectation value of X is A by 2, which is constant, time independent. So it will be equal to 0. Now we have to calculate the expectation value of p squared. By definition, expectation value of p squared is psi star p squared. Here p squared psi. So psi star p squared psi, which is this is the expectation value of p squared. But I am replacing p squared by its operator, which is minus h cross squared t2 over tx2 psi of n x dx. So this is applicable. Remember that this is applicable when potential is 0. So particularly the box, that is infinite potential well, there is no potential inside it. That means the Schrodinger equation will become minus h cross squared over 2m t2 psi over tx2 is e n psi n. This I am again stressing that point. This you can use only when potential is 0. So now you bring this 2m to the other side. 2m to the other side. Then this will become minus h cross squared t2 psi over tx2 is 2 m e n psi n. Then what about this? This is the number. When it act on, it will give this number, and of course, I forgot psi n. That is this number em, sorry, 2men psi n. So I can replace this. I am bringing this 2men 2men outside the integral. Then this is psi star psi tx is 1 by due to orthonormal property. Then the expectation value of p squared is 2m multiplied by this e sub n, that is n squared pi squared h cross squared over 2m a squared. Here I can cancel this 2m and this 2m. The expectation value of p squared is n squared pi squared h cross squared over a squared. So what is sigma p squared? The expectation value of p squared minus expectation value of p whole squared. This will be 0. We have seen expectation value of p is 0. And then you take uh, that is then this is just equal to the expectation value of p squared, which is n squared pi squared h cross squared over a squared. Now we got sigma x squared is this one, that is 1 over a squared multiplied by 1 over 12 minus 1 over 2 n pi whole squared. Similarly, sigma p squared just now we have seen is equal to n squared pi squared h cross squared over 2a squared. Now you multiply both. Sigma x squared into sigma p squared is this multiplied by this yellow color part. Here you can see this a squared will get cancelled with this a squared. So you have only n squared pi squared h cross squared outside the bracket. Now you bring this inside. Then the first term will become n squared pi squared h cross squared over 12. The second term, here you have n squared pi squared. Here also you have n squared pi squared, which will get cancelled, and you will get only h cross squared over 2. Now you take h cross squared over 4 outside, then this will become 3, and this is minus 2. So now you take square root of this, both sides square root. Then this will become h cross over 2 square root n square n pi whole square over 3 minus 2, which is greater than h cross over 2. Then the question asked is when you will get minimum uncertainty. That is minimum uncertainty. Minimum uncertainty, I'll get here you can see inside the bracket, the only variable is n. All other things are constant. So minimum uncertainty, I will get only n is equal to 1. So thank you very much for watching my video and supporting me continuously. Thank you very much.